stage with her bones. Excitable boy, they all said.
Good morning, ladies and gentlemen, here in New York City at day 3 of the 5th Cloud Expo. Good morning, good afternoon, good evening if you're following this keynote out there on the World Wide Web. We have Abiquo to kick us off this day, to reward you for your early morning start. What happens when open source meets technology innovation and business leadership? Well, I think this is what happens. It's Pete Malcolm, CEO of Abiquo. Pete, take it away, sir. We're coming from so far. Come on.
Good morning. Sorry it's so early. I had trouble waking up this morning as well. Is my clicker working? Click. 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 No clicker. Okay, the manual method. Click. There you go. I'll just say it. So I want to start off... Ooh. That woke you up, didn't it? Okay, now everybody's awake. I wanted to start off with a little bit of history, just really to show how far we've come in such a short time. So this little timeline here just reminds us that all of this stuff we're talking about is a mere 27 years in the making. Right up until the early 80s, we were dominated by mainframe, and client-server really didn't start until 83 when Novell brought in their local area network. There were a couple of people before then, but really it started with Novell in 83. 1990, and Tim Berners-Lee invents the World Wide Web, Brit, I have to say. And all the way through to 99, when we start to get the beginnings of what has now become the cloud with VMware and their first workstation product. Salesforce.com launched in 2000, and in 2006 we get to Amazon Web Services. I should try my clicker once more. No, it's manual. Click. Down arrow works well. There we go. Okay. So the cloud really starts in the 2000s when Salesforce get going. It's not called the cloud then, but that's when it starts. And just look where it gets to. Yesterday, VMware announced their revenues for the year. Their forecast revenue is between 2.63 and 2.75 billion, I think. So it shows how far we've come in such a short space. If we can move to the next one. Click. There we go. So 27 years of client-server, 20 years of internet computing, 11 years of virtualization in its 1.0, as I've coined it, role, and then 10 years of cloud. And in that time, we've seen a phenomenal, unprecedented growth in applications that are being run. Think back what things we used to run 20 years ago and compare that with the number of applications that enterprises and even small businesses are running now, and the growth is huge. But if one more click, it's the same old IT infrastructure management model. It really hasn't changed in the way that we run our IT organizations hasn't changed. And that's really what today's presentation is about, because we believe that it's got to change. And what I'm going to talk to you about today is sure, it's our view, but it's an entirely vendor-neutral view. I'm not going to mention our company or product at all. This is about how we think the industry has to, an IT infrastructure management has to change. Next one. So look at why we have the infrastructure management that we have today, how it evolved into what we've got now. And it's really all about risks. The way that the IT infrastructure team manages systems today, it's all about containing risk, and those risks come from a whole pile of different areas. So there's the risk of procurement. Will people buy the right stuff? Will they adhere to the corporate standards we need? Can they interfere with other systems that we've got going? Do they have the expertise to do it? So this is what the IT infrastructure organizations are doing in the physical world. They're containing all of these things, containing all of these risks, and organizing that all for the organization. When we talk about virtual data center risks, the risks there have reduced somewhat because the kind of procurement risks and The expertise risks reduce somewhat, but you still have big risks associated with interference. The IT infrastructure organization has to provision machines because it needs to make sure that you don't interfere with what somebody else is doing. We have to make sure that you don't exceed the resources that have been allocated to you and bring the whole house of cards tumbling down. So these risks are real, and this is why IT has to keep its hands around everything. But combine that with the huge growth in applications, and that's what leads to the problem. Next slide, please. So IT is doing all of the provisioning. We're going to try this new clicker, okay? IT is doing all of the provisioning, whether we're talking about physical or virtual machines today, because it still needs to keep its hands around all that stuff. And so the huge growth means that that's a real bit difficult problem. There we go, clicker's working again, fantastic. So let's talk about the issues with Virtualization 1.0 as far as the organization is concerned. So we've got huge amounts of virtual machine sprawl. The huge increase in the number of applications that we've got running means that there's just, IT organizations are really suffering from the overwhelming growth, having trouble keeping their arms around all the stuff that's going. And I think most of the reason for this is, or a good part of the reason for this, is that the IT infrastructure team is really disconnected from the applications. Now, that may sound obvious, but the two really don't interact that much apart from the request for provisioning machines. And that means the IT team doesn't really have a handle on what's going on the application side, nor do they want one. But that leads to a whole pile of issues. So, for example, I'll give you a very simple example of that. The application team has finished with a virtual machine, but the infrastructure team probably doesn't find out about it. And so that virtual machine is still running, and they still think they've got to maintain it, and all these cost savings that we hoped we were going to get from virtualization because of greater utilization and all those sorts of things actually hasn't really happened because issues like the machines are still running and they don't need to be. So those efficiencies are completely lost. We need something better than that. We've got a real lack of agility. It takes a long time to get machines provisioned. It's certainly a huge amount of time to get physical machines provisioned, but it's still taking far too long to get virtual machines provisioned as a backlog. And that really means that short-term projects and what-if scenarios and stuff like that are really difficult to achieve. Again, you're losing your agility. Poor capacity planning and utilization. I've talked about utilization already. Really hard to plan for capacity when you're spending your entire day, provisioning new machines, fixing fires. You're distracted from the task of working out what you're going to need in the future. And lots of security and compliance issues around virtualization. How do I segregate the data that belongs to research from investment banking if you're in the Wall Street world? How do I achieve all of that? Compliance, security. How do I make sure that the data is running where I want it to run? And here goes the big sort of public-private cloud argument. Why isn't public cloud being adopted in the same way? And it's all to do with the security that that data is sensitive. We don't want it outside our organization, and we really haven't solved the problem of that yet. And lastly, vendor lock-in. I won't labor that point, but clearly that's an issue for a lot of companies that they're locked into their supplier, and that really is artificially inflating the costs. So our contention is that the unprecedented growth of applications and the complexity of those applications has made the current IT infrastructure management model that we've had for the 27 years that the client server has been going unsustainable. And we therefore believe that the model must evolve, and that's really what I want to address with you this morning. So this goes down to our vision, which is a top-down strategic vision. We've tried to step back and think about this problem holistically, rather than trying to tactically solve an immediate problem. We've tried to go back and think about it. This is entirely vendor neutral. We're not claiming any proprietary stuff here at all. We're we're really wanting to encourage debate, and we're just putting this forward as our view of one way that these issues could be solved. And we want to talk about solutions, not about what's the latest cool technology or use the latest buzzwords. We think that there's an awful lot of confusion created in the market by seemingly innocently created buzzwords that are then jumped on by everybody else to say, oh yeah, we do that. And all it's doing is confusing the whole thing. So we'll try and avoid the use of buzzwords if we can. So here is our vision slide, and let me go through and explain this to you. But it encapsulates pretty much everything we're talking about. And you'll see here we have on the outside ring the physical infrastructure. And the first key piece of our vision is to entirely separate the physical infrastructure from the virtual enterprises, virtual data centers, the application side of the house. We separate them with that thing we've called the resource cloud, which is just a notional thing. So around the outside there, we have local data centers, we have remote data centers. These are the things that your organization may already have. Certainly big enterprises have them. We have infrastructure as a service providers on the rear left there, and hosting providers. And all of these people are, or all of these entities are, contributing resource to the resource cloud. And those resources can be servers, they can be networking, they can be storage. All of those things are contributed. And then on the inside, the virtual ring there, the gray ring on the inside, those people are the consumers of the resource. And when one of those data centers, enterprises decides that it wants to deploy a virtual machine, then the actual deployment of that is obviously goes out across into the physical world. But the virtual enterprise neither knows nor cares where that physical machine actually gets deployed. Now, there's a caveat to that, and the caveat is that you need to do that in accordance with a policy, but the actual machine that we end up on doesn't really matter. So the ability to manage and deploy virtual data centers and virtual machines is delegated to the virtual enterprise. And here is the big change, the big difference. The IT infrastructure organization no longer needs to be responsible for deploying and managing virtual machines. What happens is you create a virtual enterprise, and that's just a logical unit, and you assign someone to be the administrator of that virtual enterprise, and you set resource limits as to what that virtual enterprise can consume. And resource limits are things like, today we think about things like CPU cores and memory and storage and public IPs and stuff like that. You set what that enterprise is allowed to consume, and then you hand over control of that enterprise to the enterprise administrator that you've appointed. And they are then free to do all of the virtual machine management tasks, the deployment of new machines, the creation of data centers, appointing other users to work in that enterprise, to manage it in various different roles. You've completely delegated responsibility. But you've done that in complete safety, because the risks we saw earlier, the risks of interference with other systems is gone, because the actual provisioning of machines, the actual selection of which physical machine that's going to run on is all isolated from the user. They just say, deploy the machine, and a workload policy determines which machine it will actually end up running on. And we'll talk about the policy in more detail. But the virtual data centers don't get anywhere near the physical machines. They don't do the deployment, the system does. And the second risk of interference with others is completely gone as well. The resource limits make sure that any virtual data center can't exceed the limits that it's been set. So you can't suddenly decide, okay, I'm going to deploy 100 cores and take down the physical infrastructure because you've overloaded it. That's no longer possible. So this is the change, and that's it means that the IT infrastructure organization no longer has to provision those machines, and we get a whole bunch of other benefits that we'll look at in a moment. In the center of the graphic there, you'll see the image libraries, and the image libraries are containers for virtual machine images that have been created. And they exist in three different layers we can see there. A private library which is available only to the virtual data, to an individual virtual data center, and there you store obviously images of machines you want to deploy, and snapshot copies of backup copies of machines, all that kind of stuff. You have a shared library, and a shared library could be shared across a whole virtual enterprise, or indeed all of the virtual enterprises in a company. And here would be images that perhaps have been created by the IT organization, the infrastructure guys. So for instance, we may have, okay, here's an image of a standard Windows 2008 server or a Linux server or whatever. And here is it's already set up with all the antivirus we need, with all the management tools that we need, and they're ready for you to deploy. And you may decide that you want to restrict what the virtual data center can do to just beginning with those images that you've created. You may allow them to bring their own images. You may also, we take the public layer at the top, you may allow them to pull images down from other vendors, trusted vendors, and incorporate those as well. We see a move towards software being delivered as virtual images rather than as packages, which you have to install the OS and you have to install the application and all of that stuff. It takes a long time. We see a move to distributing servers as application servers as virtual images, and they're in the public library. So the foundations of what we talked about are these three key pieces: the separation, complete separation of the physical infrastructure, which is still managed by the IT organization, and they're delivering that into the resource cloud with whatever SLAs are appropriate. The delegation of responsibility for the application services delegated to the people who are actually at the coalface, the people actually running those applications. And the allocation of machines when you actually deploy a virtual machine is done automatically for you, and that happens in accordance with the workload policy. Together with the workload policy, you also get two other kind of sub-foundations here. Multi-tenancy. Not only can you delegate, you can also do so in a multi-tenancy way, so you can have completely isolated virtual enterprises. So if you're a hosting provider, you can provide a virtual enterprise for each of your customers, and the administrator's view of that virtual enterprise, their view of the world is just that virtual enterprise. So they create, they don't see any other users other than themselves and the people below them in the hierarchy, and they can, completely segregate and create their own environment, their own world, if you like. And then the image libraries that we've already talked about. So the separation, as we talked about, takes the cloud providers. They are the contributors into the cloud, the local data center, the remote data center, infrastructure as a service, in other words, resources that you've bought in from an IS provider. It could be like an Amazon, or from a hosting provider you've bought in extra resource. And this gives you complete elasticity. You've got the consumers, the virtual enterprises, the data centers, and within those virtual appliances. And a virtual appliance in our terminology is a collection of virtual machines. So you can imagine that let's say we want to have an appliance which is a web farm. And we make that up of 5 components, perhaps a load balancer, 3 web servers, and a database server on the back end. We can package those together as an appliance and deploy them in a single drag and drop operation, so that you make deployment really, really easy. So just look at how this is a sort of pictorial view of how the delegation works, and you can see the effect. At the moment, if you look at the top bar there, that shows you how it works today as the virtual machines expand. So the work that the IT organization has to do, the management that it has to do, is just expanding horizontally. And what we've proposed is, in the Virtualization 2.0 model, by delegating that, you turn it into a hierarchy of small numbers of virtual machines, which are much more manageable, and what's more, they're being managed by the people who actually have knowledge about them. And that becomes a completely scalable model. You can continue as far as you want. Policy-based allocation is really important here. How you determine where a virtual machine is actually going to be run. And there are a whole lot of different dimensions to this, and I'm sure there will be more dimensions that come in the future. But there are the obvious functional ones. I can only deploy a virtual machine onto a physical machine that's running the right hypervisor as the first clear item there. The second, obviously, I can only deploy it on a machine that's got sufficient resources to run it. So, if I've determined that the virtual machine image needs 4 cores, for example, and I can't deploy it on a machine that's only got 2 cores available, for example. So when you're doing the selection process, the kind of first cull is to determine which of the physical machines are candidates. Then you might bring in standards like security and compliance and segregation. So security is saying things like, this is our sensitive accounting data or our trading data. This must stay within our organization. So we've got a policy that's set that says trading data doesn't go out. So if you know that the enterprise or data center in question is being managed by the trading group, you know that data has to stay inside. And similarly, compliance and segregation, again, take the banking world. Investment banking information must be separated and segregated from research information. So you may have a policy that says this rack of physical servers is going to be reserved for research data, and this one is going to be reserved for investment banking. Or alternatively, you might do it dynamically and say, you've got to put this in a rack that does not already contain this kind of data. So you do it on the fly. And again, cost is a factor here. Whether you want to place this in, you want to restrict the amount of storage or resources that you use based on cost could be a factor too. So we rate the HR systems as lower priority and must use lower cost hardware than the trading systems, which can use the expensive stuff. And then operational issues as well. And here we get into some interesting possibilities that again are impractical when allocation is being done by humans. How about the prospect of, we know that systems are very often underutilized, and that when, if you ask somebody what resources they need for a particular application, they almost always overstate the resources that they actually need. And the expectation thing is going to expand and all that kind of stuff, but you don't get anybody ever underestimating what resources they want, or pretty rarely. But the result of that is that you do still get machines that, although notionally they're loaded up as far as the applications have requested, in fact you've got a big underload situation. So what you can do is to overload by saying, I want you to actually use 110% capacity, 150% capacity. And you can do that as a policy decision and then have that reflect upon all of the, as virtual machines are deployed, you can have that brought into play entirely automatically. Again, that's not something that works if you've got humans deploying the machines. It's not possible to keep all that stuff in play. And then you've got preferences that might be set by the virtual enterprises themselves. You might request that your virtual machine be deployed locally or be deployed in a particular data center. You might do that for reasons of performance. You might do it for reasons of resilience. So you might say, I need, I've got 2 virtual machines I'm going to deploy here, but this is a resilient pair, so they must be in different data centers. And that can be determined not by the global policy, but by a local request in deploying those machines. So lots of different dimensions to that workload policy, and we're sure that many more will be thought of as time goes on. So just to talk about some of the stakeholders here. Clearly the IT infrastructure team, they're controlling the provision of resources to the cloud, the physical resources, whether they get those locally or whether they buy them in. They're maintaining the physical infrastructure and making sure those resources are delivered to the SLAs that are required. And they create the virtual enterprises to begin with and set the resource limits so that overall they can make sure the resource limits aren't exceeded. They're in control of those still, so the house of cards doesn't come down. The virtual enterprise administrators are controlling the consumption of the resource cloud. They've got their resource limits set, but within those limits, they control what happens. They control the users that are appointed to manage their various enterprises, and they can delegate control of those data centers, management of those data centers to them. And the CIO level dictates what the workload policy should be. What can exist with what, how we're going to deal with loading, all those sorts of things can be dealt with at a sort of corporate policy level. So the benefits of this solution are, first of all, a dramatically reduced load on the IT infrastructure team. They're now not spending all their time in the drudgery of deploying virtual machines. They can concentrate on the physical infrastructure, maintaining the service levels, capacity planning, all that sort of stuff. They can drop managing, they've dropped the management of disconnected machines, so they're not worried or concerned about what's happening in the virtual world. That takes care of itself. They just need to worry about the issues on their side of the house. They don't need to worry about machines not being taken down and that kind of stuff. The virtual side deals with that. They can make sure that the risks remain eliminated. We're not introducing any extra level of risk here, which is the reason why, as I've said earlier, IT is run exactly the way it is now. And they can ensure that standards are maintained and as we've said, do more capacity planning. So, they can start to be proactive rather than reactive, which is what's happening a lot today. We've got a dramatic increase in agility because I can now, as a virtual data center or virtual enterprise manager, I can now deploy a machine in seconds. I don't have to wait and go and ask IT to do it. I can do it, conceptually with a single drag and drop operation. If I want a machine, available, not in 30 minutes, but or 3 days or 3 weeks, I can have it ready in, 15 seconds if that's what I want to do. Have it up and running. And I can, take it down, modify it just as quickly. So a dramatic increase in agility. So I can do those temporary projects, those what-if scenarios, all that kind of stuff. And the overall effect of this, we believe, will be a dramatic increase in utilization. Not only because we know more, we're in more control, but the workload policy allows us to determine how we want that utilization to be. And think about two different extremes in load balancing. We may be an enterprise that has a lot of hardware and is very concerned about the performance of our applications, and we may set a policy that says, I want you to spread the virtual machine load across all of our physical hardware in as kind of a thin layer as possible so that I maximize the performance of every application. You might be a hosting provider where you want to do exactly the opposite. You want to make sure that each of your physical machines is completely loaded up and is utilized as much as it possibly can be before we move on to the next machine. So two different, and obviously everybody will be somewhere in between those two extremes. But these are things that are available to you when you're talking about allocation that's done completely automatically according to policy, not determined by humans who'll say, oh, well, I'll just put it there. And lastly, the security and compliance issues. You can now, even without having to go to the expense of huge complex switches that are creating individual LANs on demand, you can start to do things just with ordinary VLANs and say, okay, well this rack I've got on one VLAN and this rack I've got on another VLAN, and workload policy can just be designed to make sure that data is segregated. I don't need to go into the networking level necessarily to do that. If I know how I've set up my VLANs in advance, I can tune the policy to work with those. So just a few use cases here. Clearly, I've talked a lot about enterprise data centers, and you can see how that can give you centralized management of your entire infrastructure, both physical and virtual. How you can get the elasticity using your local resources, your remote resources, and purchase in resources as you need them. But this is equally applicable down at the sort of small development team level, giving you very rapid deployment, giving you total flexibility, even in small installations. Clearly, there's a model for hosting providers They can sell virtual enterprises, as it were. So instead of saying, here is a server that I've set up for you, here are the credentials for the server, you can move to a model which says, okay, here's a virtual enterprise I've set up for you. You can manage it yourself. You've purchased these resources, and you can do that. You can charge for it on a basis of what resources you've allocated, or on the basis of what resources are actually being consumed. Either model works. Or you can just sell resource to be provided into somebody else's resource cloud. And this is one of the things that gives you elasticity. So as a hosting provider, I can sell resource to an enterprise who needs more capacity than they've currently got. And right down to the SME level, you can be an SME and have all of the benefits of running your own data center and control of running your own data center without any hardware. You can, if you choose to, completely get your physical, your resources from a hosting provider. But you're isolated from all that nastiness of running those physical machines, yet you get the same ability to control and deploy your own VMs on them, just like if you had them in your own data center. And then there are a whole bunch of extensions to this basic model. I've talked a little about billing and chargeback already, so you can, as a hosting provider, but you can be, clearly as a hosting provider, you can be charging your customers for these resources, but as an enterprise, you can be charging departments for the resources they consume. And then you're obviously going to encourage efficiency and utilization and make sure that they're taking down machines that they don't need, because it now saves them real money to do that. And ultimately where this model goes is into the brokered provision of resources, where you can, this separation allows you to create ultimately a marketplace where you can buy resource at whoever's the cheapest available, and you can start doing things like dynamic load shifting so that you can automatically be moving virtual machines from currently expensive stuff to cheaper stuff, and you create a complete brokered marketplace to do that. That becomes possible with this model as well. You can introduce active load monitoring. What I've been talking about so far has been largely passive, saying when you allocate resource, you're going to the virtual machine is going to virtual enterprise is going to say, I need this much resource for this machine. But you can start to actively monitor not just what they've asked for, but what they're actually using. And you can start to do automatic overloading, if you like, because you know that although the resource has been allocated and even the resources being paid for, they're not actually using it. So while I've got spare capacity on that machine, let's overload it in the kind of airline seat model, overselling. The difference is that when an airline, when everybody shows up and you've got overbooking and they have to ask for volunteers, you don't have to do that here. You can just shift it off someplace else automatically. And lastly, this starts to bring in things like energy efficiency. If we're talking about a model, the load balancing model we talked about for a hosting provider, you start to integrate this with some of the technologies for physically turning servers on and off. You can say, right, I'll turn all those servers off. We're not using them. And yet when I need capacity to, the virtual machine comes along that tips the balance into needing another machine, we start it automatically. All of those things become possible as well. So in conclusion, let's remind ourselves of the three cornerstones of this, the separation, the complete separation of the physical infrastructure from the virtual consumption, the delegation of authority to administrators of a virtual data center. They can get on with the job, and that gives you the multi-tenancy. And the automated allocation according to a workload policy. So that's the model, and what I'd like to do now is to get Jeremy to open it up to questions. We want this to be as interactive as possible. And I think, Jeremy, we're also going to repeat the session a bit later on this morning too.
At 11:20.
Pick a microphone.
They will be live in a minute. Yeah, at 11:20 for people who didn't get the beginning, because I saw people coming in late, heaven forbid. Anybody out there with a question about the resource cloud? See, it's very early morning, but I think the questions are going to come second time round.
Everybody's still asleep,
Yeah.
so we'll
Second
get a chance to
time
do it
round
later.
questions. Okay.
So there's a lot of optimism about the cloud environment and the approaches that it's being taken. What are the things that would either deter, slow down, or not make this technology transfer happen?
I don't think there are any. Clearly, you've got to. One obvious thing is you've got to have vendors who are providing stuff to this model. Products have got to be available for you to do that. Of course, I'd blow my own trumpet. So that's clearly an issue. You still have this doesn't resolve the issue of security in data security outside of your own data center. That's not resolved by this. I think that issue will be resolved quite soon. Excuse me. At least as far as infrastructure as a service is concerned. I think it's relatively straightforward for hypervisor vendors to provide a hardened version of their hypervisor, which gives you a ring of steel around a virtual machine. We don't have any issues with, we all know how to communicate with a remote device in safety, so actually getting stuff to and from it is fine. The risk is, who else is peeking into that? It can peek into that virtual machine. I think that can be solved by hypervisors. I think a much more difficult area is if you were trying to consider this as software as a service rather than, I think that model to solve the security issue there is much harder. You really can't, you can only do it by having a third-party audit and you believing that, if you take Salesforce.com, for example, it's very hard to be convinced that an employee of Salesforce.com can't see the data. You can only be convinced that the risk is low by some third-party independent auditor going in and saying, yes, the procedures are in place to stop this. It's very hard to do that in a general sense. So, but I think you can do that for infrastructure as a service by having a hardened, hypervisor that creates a hardened machine for you.
And over here.
So you talked about brokering. So I suppose brokering externally probably is not possible right now.
No, that's a future. But what I'm saying is that the vision that we've got and the model we've got there would support brokering in the future. Now, of course, all sorts of other things have to happen there. Standards have to be established about APIs for broker. Between those people providing into the resource cloud and those people consuming it. You need APIs there to do that. But in principle, the model works to allow you to buy your resource from anywhere. On demand any time, and to switch your allegiance to somebody who is providing cheaper infrastructure to you.
Yes, makes sense.
Well, the other thing is, I suppose, can you do internal brokering? So I suppose that's what you meant by.
Well, internal brokering is certainly possible. You can do it internally or you can do it externally. But what I was trying to suggest there is that this model allows you to ultimately get to a situation where we have a marketplace for resource. Because it's completely separated from the consumption of that resource, the IT infrastructure organization can conceptually buy that from anywhere it wants. And because we've got the dynamic allocation, the policy-based allocation of virtual machines and the ability to move virtual machines, all of that can be done in the background. So it makes those kind of things possible. I'm not certainly saying that is even close to a reality today, but the model, the vision supports that when you get there.
So how long will it take to get there?
How long's a piece of string? I think the only thing that I would suggest is that if we take Virtualization 1.0, that was a 10-year project to go there, and I think that. That was an extended time period for two reasons. One, because it was a completely new concept, completely out of the blue, and the second was, I think, whilst the sort of development community was able to buy into it relatively quickly, the big buyers ultimately were the enterprises, and it took a long time for the enterprises to believe that they were going to trust a production machine to a virtualized environment. That's quite a big step to do that. My argument would be that we've got past the tricky stuff. That was the tricky stuff. Nothing in what I've suggested here changes the way an individual virtual machine works. So we don't have to overcome that hurdle. We're just talking about the management piece. Nothing I've suggested affects how an individual virtual machine works. Maybe where it runs, but not how it works. So I think the step is much shorter. So my guess is that we're actually talking about a potentially much shorter period here. The key, of course, will be to establish the standards so that it's a real marketplace that everybody can participate in. And I would suggest to you that standardization won't come from the big vendors because it's not necessarily in their interest to do it. I mean, we have a lot of standards talked about today. We don't have many standards in reality because of vendor lock-in and those sorts of things. I like to talk standards, but I don't actually really want them.
Candid talk.
Thank you.
I'm going to. Are you able to come back at 11:20? Yes, because then we can keep those questions going.
Perfect. Okay.
Yeah.
And
they
what I'd
have
also,
sessions to get.
Jeremy, what I'd also like to do is to, if I can have two more clicks, in fact. We'd really like this, as I said at the top, this is not proprietary to us in any sense. We're just proposing this as a kind of thought leadership thing. Clearly we believe that we'll take our product in this direction, but we want this to be input from everybody else too. So don't go to this site now; it's not there, but we'll get it up in the next couple of days and as a kind of information and blog site. Entirely neutral, and we'd like everybody's contributions. Your thoughts on what I said that was right, what I said that was wrong, what you think doesn't work, what you think's missing, what you think new possibilities could be that we haven't thought of. Let's move the debate on.
Excellent.
Thank you very much.
Thank you to Pete Malcolm, CEO of Abiquo,